using the fact 1,764 divided by 28 equals 63, find each quotient. So we talked about this in class, that I'm noticing a pattern that if I'm moving a decimal, I'm still going to have the same quotient, right? My quotient still should have the digits 6 and 3 in them, but it might be 6.3. It might be 0.063. It might be 63. It could, right? So I'm noticing patterns. So when I'm moving these decimals, I'm starting to, notice, where could this, if it's 28, and it goes into 1,764. Well, yeah, no, and I added a 0, so I'm going to add a 0 to my quotient, which I normally had 63, then it becomes 630. When I move the decimal points for number 11, I end up back where I started with 1,764 divided by 28, so the answer is 63. When we notice things like this, it makes us have light bulb moments like, oh, okay, yes, that's what you were talking about. I know I feel like that sometimes too. So this case, it's 630 because I moved my decimal point and I added a 0 to my quotient. Move my decimal, it's 1,764 divided by 28. I could rewrite it below here. And I'm back to where I started. So the answer of 63. Move my decimal, 28, and how many times does that go into? 176.4, so that's going to be 6.3. No decimal to move on my divisor, so it is 0.63. So we're so used to reading left to right, when we see, oh, there's the dividend, there's the divisor, or there's my divisor, there's my dividend. However, it's written in a word problem that when we see it like this, like number 17 through 20, it's kind of weird because we see the number that we're going into first. Things get crazy. So I need to move my decimal point. 9 into 180 is my final. So I know it goes in there 2 times, 0, bring down a 0. So my answer is 20. And that's because I moved my decimal on both sides and I attended to precision. So an answer of 20. Number 18, 0.7, and that's going to be on the outside. And on the inside, I have 21. Now my 0.7 becomes 7, and my 21 becomes 210. So I already know 7 goes into 21 3 times. 7 can't go into 0, so 0. Answer of 30. Number 19, 3.2 divided by 0.8. I gotta move my decimal over, and on the 0.8 becomes an 8, 3.2 becomes a 32. So because I know how to math, I know it's 32, I subtract it, I get 0, I follow through. And with this, there's no other number to pull down, so my answer is just 0. So I set it up, I move my decimal 1, 2, and then it's 4. How many times can 4 go into 12? 3. Number 21. Rona is buying storage boxes for her CDs. Wow, they really like CDs here. She has 456 CDs. Wow. Each box holds 36 CDs. How many boxes will she need? So I'm going to set my problem up just like this. I have this big number, and I'm wondering if each of them holds 36, how many boxes is she going to need? Now, when I'm dividing it, I'm thinking, okay, so 36 can go into 96. 3 times would be too much, right? And you'll see, I'm thinking like, well, what's 3 multiplied by 3? No. So let's do 2. 2 multiplied by 6 is 12, carry the 1. 3 multiplied by 2 is 6 plus 1 is 7, so 72. When I subtract, I get 24. That 24 is like, hey, you left me out. Now we have to take account of those 24. We can't just say I can only buy 12 boxes. I'm going to buy that extra box